Hello everyone. The element I'll be talking about today is element 43, technetium. Technetium is a special element because it had actually baffled chemists for decades. They knew that element was there but couldn't find it. The reason why chemists knew an element was there is due to Mendeleev predicting that there was an undiscovered element due to the gap he left in the periodic table. Decades after Mendeleev made that prediction, technetium was discovered by Emilio Serge and Carlo Perrier in Sicily in 1937. Emilio Serge had previously visited Columbia University and Berkeley University and managed to convince the inventor of the cyclotron, the thing that bombards an element with a particle, then there's an effect. Ernest Lawrence, who was the inventor, to mail him old parts and used irradiated molybdenum foil. Sergey and Perrier tried to separate and purify the molybdenum foil to find element 43 and were eventually able to isolate technetium-97. Technetium was actually the first element to be produced artificially, and today technetium is mainly obtained from spent nuclear fuel. And now I will pass it on to my colleague, Ibn Battuta. Oh, yes, thank you very much, Adnan. And now off on chemical properties and reactivity of technetium. Yeah, so technetium has no stable isotopes. They're all radioactive. Technetium also does not like to form cations, which means it doesn't like to give electrons, which is unusual for a metal. It has an average electronegativity of 1.9, and technetium has similar properties to its neighbor, rhenium, which makes sense. They're in the same group. Rhenium's right under technetium. And because of those similar chemical properties, just like rhenium, it doesn't oxidize very well. And um, the isotope technetium-99m also bonds to biological molecules and is used for radiopharmaceutical imaging, which I will go into more detail in the important compounds section. So the most notable and widely used compound of technetium is sodium pertichnetate, or not something like that. I'm not too sure. I bet professor can correct me on that. But the reason being, this compound is used to derive the aforementioned isotope technetium-99m. And technetium-99m is used, as I said before, in radiopharmaceutical imaging to help diagnose different cancers because the patient ingests it and it binds to, stuff in your body, and then they can take the images and see, oh, you have that there or that there. And the reason why it's used and not another isotope of maybe another element is because it has a half-life of 6 hours. So it's not that dangerous. Still is, I mean, it's not completely safe, but it's not that dangerous. And another compound of importance is potassium per pertechnetate. So same thing as the sodium, but there's potassium now. And this compound is actually used to protect steel from corrosion and is apparently very effective in small amounts. So that's pretty cool, and that concludes my presentation. Yay! Thank you all.